can see it. Hi, this is Miss Litton, and this is my wonderful Period 2 Honors Bio class. Say hi.
Hi.
And we are about to talk about the cardiovascular system. This is chapter 12. We just watched a great little song, and we're moving into compare and contrast the three blood vessels. Okay, I want you to look at a couple of things on each. First thing I want you to look at is the lumen. Do you know what the lumen is? If somebody says, this is a lumen, the lumen of your nostril. It's the opening or the space. Who has the larger lumen? An artery, a capillary, or a vein?
Vein.
Vein. Okay, so here is the lumen, that opening. Here is a lumen, and here is the lumen. Okay, so, you're so cute. On the lumen, why would a vein need a larger lumen than an artery? Any guesses? Why would you have a larger lumen? Yes?
Are you like carrying the carbon dioxide waste with it?
Am I carrying the carbon dioxide what? Say that again?
Waste with it? Like,
Okay, so yeah, there's waste in there. Could be. It depends on the vein. Something else. Yes? There are valves in the veins. It's another reason. Still not what I'm after. Yeah.
there's less pressure. So
There we go.
you don't have to be still.
Yeah, so if you take all your blood and divide it in half of it would be in arteries, right? Half may be in veins, but which one is under the greatest force? Arteries. Okay, the speed, arteries, right? So you have a larger volume that can move faster through an artery than you would in a vein, so you need to have more room, right? In order to have the same amount of blood that's going out is coming back in. All right? Next thing I want you to look at is muscle. Who has more muscle, artery, vein, or a capillary?
Arteries.
Artery. Okay, so if I look at the muscle, here's the muscle for an artery, vein. Oh, there is none. Okay, for a capillary. Why would you have muscle in an artery? Yes.
Because it needs to go back up the body.
It needs to go back up the body. Let's think about that more, though. I need more. Flesh that out for me, literally. Why would you need more? Why would you need muscles in an artery and not as much muscle in a vein? Yes.
Because the blood has to
Where is the blood under the greatest force? Artery. So they have to withstand the surge on the arterial walls due to the heart contracting and forcing that blood out of the heart. Think about it. When your heart contracts, it's got two destinations. It's sending some of the blood to your lungs to get what? Why would it send blood to your lungs?
Oxygen.
To get oxygen. It's sending some blood out to the whole rest of your body. So it's got to get all the way out to the farthest parts of your body and not start to backflow. So that blood is under, a lot of pressure, and so when it comes surging out, you don't want the arterial wall to distend and stay distended or break in some way. So you have to kind of keep it to keep the blood flowing in one direction. You want it to snap back. Take your pulse right now, either at your neck or at your wrist. What you're feeling right there is an arterial wall, expanding against your fingertips. And then it's going away, right? You feel it, and then it goes away. That's the snapping back motion of the arterial walls. That continues to keep the blood flowing in the same direction. Now, as I start to talk about blood, I'm going to tell you, it is not unusual for a couple of students to have a hard time when we talk about blood. I want to pause just for a second. Okay. All right, so we're back. All right, so we've talked about the lumen being different. Yes, Mikey? Oh, okay. So we're going to stay focused here. The lumen being large, we're talking about the muscle being bigger so that it keeps the blood flowing in one direction. What's another difference between arteries, veins, and capillaries? What's another difference? Yes?
One carries oxygenated blood, the artery does, and the vein carries.
Is that a true statement?
No.
No. But a very common misnomer. That's true only in the systemic circuit. Okay. The definition of an artery is it carries blood away, away from the heart, and the definition of a vein is it carries blood towards the heart. Now, is there any blue blood?
No.
No blue blood. It just looks like blue through the connective tissue. What's another difference between arteries, veins, and capillaries? I heard somebody said it earlier, but it was The wrong answer to a different question. But a good observation. Yeah.
Does it veins have valves?
Veins have valves.
Veins.
And what is the point of a valve? Keep blood from moving backwards. Okay? Think about it like a tube of toothpaste. If you had the cap off the end of a tube of toothpaste and you grab the toothpaste in the middle, what would happen? It squirt out one end, right? And that's what those valves do. Because think about it, when you have blood in your big toe right now, it's got to get all the way back to your heart. What's going to be saying, blood go down? Gravity. Okay, so gravity is going to want to have it pool just at the bottom of our feet, you know, and have all this blood, you know, swollen into our feet. But because what happens is our skeletal muscles contract and they push against the collapsible walls of the veins, and when they push against those walls, it squishes them, and the blood can only move in one direction because of the valves, and it keeps it going in that direction. So that's a critical part. What's one more super obvious difference between an artery and a vein and a capillary? Yes? Capillaries are much smaller. Capillaries are 1 cell thick. And the reason why they're 1 cell thick is this is where all what takes place? Exchange. Yeah, you could need oxygen right here in your neck and an artery could be going by there. It can't help you out. It can't because the walls are too thick and it doesn't allow for what? It starts with a D. Diffusion. Okay, good. So now let's learn a little song, not the one I showed you earlier, okay, to remember about the structure. So we're going to build on it. First thing I want you to do is I want you to make an A. There's an A like this, and I want you to put it over your heart. Okay, now a lot of people, because we go, put your hand on your heart so we can say what? Pledge allegiance, we go like this. Is your heart over here?
No.
No, your heart is not over here. The reason why you feel your heart more on your left side is because that's the biggest part of your heart is your left ventricle, so you feel it more over here, but your heart is dead center. Okay? Make your A, put it over top of your heart. Repeat after me. Listen. Arteries go away from the heart. Arteries go away from the heart. Now flip it up. Veins go towards. Put it together. Arteries go away from the heart. Veins go towards. Perfect. Oh, is that? I didn't know that was Justin Bieber.
Please don't.
All right. Now, here's your artery. Arteries will branch into smaller arteries called arterioles. Then those arterioles will become capillaries. Then those capillaries will rejoin into tiny little veins called venules. Then the venules will rejoin back into a vein. So the order, repeat after me, arteries, arterioles, capillaries in the middle.
Capillaries in the middle.
Why do I go like this?
Because they're kind of, you don't repeat that.
Changed on. Okay. Okay, venules.
Venules.
Veins.
Veins.
Put it all together. Arteries go away from the heart. Veins go towards. Arteries, arterioles, capillaries in the middle, venules, veins. Perfect. Okay. So let's break it down. Each one. We'll start with the artery. And on your notes, what are you going to put there on the function? Takes blood
Away.
from the heart. Number 2, thick, muscular, good. Thick muscular walls. Number 3, arterioles are the smallest arteries. Capillaries, function, all exchange. All exchange of gases, nutrients, and waste. Now let's talk about that. Look at this artery for me, okay? You can see the thick muscular wall, the innermost layer of the artery, this layer right here, this innermost layer, okay? What is it called?
Endothelium.
Endothelium. So when you look at a capillary, all the capillary is what? Endothelium. The endothelium layer is continuous throughout your entire circulatory system, through the entire pathway. It lines your heart, it moves into the veins, everywhere, okay? So that is the one continuous part. So capillaries function all exchange of gases, nutrients, and waste. The structure, how many cells thick? One. Now, when you move from an arteriole into a capillary bed, okay, here's a venule and a vein, Not every capillary bed in your body is open at the same time. If I had a magic wand and I said capillarius dilatus to all of you, and all your capillaries opened, and there are little sphincters this way, on either end of the capillary bed, okay, there are these sphincters, and they open up and they'll shunt the blood into that capillary bed, and then they'll make it go away. Because if you took all your blood and tried to spread it out into all your capillaries, your blood pressure would
Drop.
and you would
Die.
No, you wouldn't die, but you would faint. Yeah, you would faint due to lack of oxygen. So you're constantly shunting the blood like here. You can't leave it permanently like closed off because those cells need oxygen and nutrients they need to get rid of. Carbon dioxide and waste. You can't leave it permanently away. Now, think about when you exercise. You all exercise, yes? What happens to your face when you exercise?
Red.
You get
It's
red.
Now, some of you are the full face red. I am the full face red. Some of you are full face and it kind of drags into your neck a little bit. Some people are the full on cheek, right? There's a, okay? So, why does blood move into our face like that?
Oxygen?
Think about it. Why would blood move into our face like that? Yeah.
Well, when you exercise, your heart starts like pumping faster, so there's like more blood rushing to your head.
Something, yes.
Aren't the capillaries here like thinner so that they can fill up more quickly?
No, looking for something else. Why would it be adaptive to shunt your, think about, does your skin get red too if you've been working out and it's hot?
Pretty much.
Yeah, your whole body can get red. Yeah.
Maybe it's because like there's so much blood flow that the capillaries kind of like break maybe.
If they
No,
Blood-
no break,
blood-
you'd be bruising.
If they broke,
That's
I'd
called
be dead.
hemophilia, okay?
Uh-oh.
Something else. What happens when you're exercising? You're generating what? Heat. How can we cool ourselves?
Sweat.
Sweat.
Okay, sweat is one way, and another way to cool your blood is bring it to the surface of your skin and allow it to cool.
Ah.
Okay. Your circulatory system plays a major role in homeostasis. Okay, conversely, if you are climbing Mount Everest and it's super cold for long amounts of time, your body has got to make a decision. They've got to say, do I keep everything alive or should I focus on my core body temperature, my brain, my heart, my lungs? So what it ends up doing is it shunts blood away from what?
Your skin.
Fingers and toes. And what can that lead to? Frostbite. Because if you have blood away from there for long amounts of time, then that tissue is going to die, and it actually kind of gets black and gross, and sometimes they just have to cut it off.
Yeah.
Or the ends of noses sometimes will get frostbite really bad, and they'll have to remove that because your body's saying this is the part we have to keep warm. So what does that? These sphincters. So your sphincters are constantly moving. What did you get told when you were little and you were growing up, and they said if you ate something, there's no for how long?
Swimming.
No swimming for how long? Yeah, they would say 30 minutes or an hour, right? And the reason is when you are eating, then you're going to want to absorb those nutrients around your intestinal tract. But if you then immediately go swimming and you're using your muscles, and you know this from, you don't have a big meal before you work out. You might drink a power bar or a good shake, protein shake or something, right? But most people are not going to eat right before they work out because you're afraid you're going to what? Throw up. Because you're going to be shunting that blood and when you're working out to your muscles, and you're not going to be around your digestive tract, and that's what's going to make you sick. So you're constantly moving the blood to where it needs to be, but no one cell is going to be without oxygen for, it's just seconds, that it doesn't have that oxygen. Okay, so for your notes where it says, yes?
Is that why when like it's get really cold, you get all pale and stuff?
Yeah, that could be part of it, yeah, absolutely, because your blood, you can't afford to send the blood to your surface, yeah. So not all capillary beds are open at the same time. Sphincter muscles regulate. Sphincter muscles regulate. Okay, and now let's move into the vein. And you guys pointed this out about the valves. But the veins, their function, it takes blood toward the heart. Takes blood toward the heart. Number two, the structure. They have a larger lumen Blue tail slate, what is lumen?
Tell me what is it.
It's the whole, like, most things, like,
Close enough.
this is the lumen.
What is the lumen?
Opening.
Good. Okay, larger lumen and something that prevents something. What else do they have?
Valves.
Valves that prevent backflow. Valves that prevent backflow.
What's the sphincter?
Okay. And then venules are the what veins?
Smallest.
Smallest veins. Perfect.
No, that's it. My turn. You've done enough.
Okay, think of a number between 1 and 100 and tell your bio buddy that number.
76.
Did you tell the number?
Yeah.
This is my number.
What the heck? What the heck?
I guess 3.
Oh, you guys three. Okay, whoever's closest to my number, pass or play on describing. How are they similar? How are they different? Go ahead.
Okay, veins have valves, and they go up into their back foot. Arteries are a little skinnier.
Yeah, you never have to ask.
And they got muscle around, and they can stop up. Arteries carry it away from the heart. Veins carry it to the heart. And the veins, I'm tired. And the veins have a bigger lumen. The arteries have a smaller
All right.
lumen. The veins have less muscle. Arteries have more.
Here is an actual artery and vein.
Oh, how pretty.
You can see the difference in the lumen. You can see the difference in the muscle. Okay, and you've got the pathway there on the bottom. Slate asked Blue 1 good quiz question. Don't let them look at their notes.
What is the order of
Artery, arterial, capillary, venular.
Good job. You didn't even look at your notes.
Or that arteries.
Why am I doing this? The human heart.
Okay, that's it. Back. Okay, next part. Heart. Okay, the heart has 4 chambers in it. Okay, 2 of them are atria and 2 of them are ventricles. And we want to understand how the blood moves to the heart and the purpose of each of those chambers and those valves. You will understand this easy peasy, no memorization, if you can remember 3 things. 3 things. You ready? Okay, thing number 1. Arteries go
Away
Arteries go away
from the heart.
and veins go
Towards.
Perfect. Second thing you need to remember are your lefts and your rights. Okay? Yeah, it's not that they're opposite. Okay, left is still left and right is still right. Okay, that part is the same. But you need to, when you're naming structures, pretend that it is on you. Your left, your right. Okay? So if somebody said, I need to amputate Emma's left arm, okay, she's right here. So if I look at Emma, I'm the doctor, I come in and I go, oh, okay, let me amputate Emma's left arm, okay? So is that Emma's left arm?
No.
No, okay? So you have to think of it on her, like your patient or on your personhood, okay? So when you imagine the heart, then you want to think things on this side over here, this would be on somebody's right, and things on this side would be on somebody's left, okay? So thing number 1 is you need to know arteries go away and veins go towards. Thing number 2, you need to know your lefts from your right. Okay? Got that? Lefts and rights. Third thing you need to know, whenever you want to refer to the lungs, bless you, whenever you want to refer to the lungs, you say the word pulmonary. Say it.
Pulmonary.
Perfect. 3 things to remember, blue tail slate, what those 3 things are.
Unlikely.
Arteries go away from the heart, veins go towards. Left and right. So we look at it as if we're talking about basics. The left and right.
Okay? Now come back to me. We're looking at a cross section of the heart. This is not a good representative of size when you look at a drawing like this. It can be misleading when you see a diagram, though they often show up like this. This chamber right here is actually the largest chamber in the heart. Now, what side is it on?
The left.
It's on the left side. This is the left ventricle. It's the biggest, strongest part of the heart. This is why you pledge allegiance over here, because you feel that left part. It's just turned sideways a little bit. Okay? This chamber right here on the top, and there's one over here, it's turned so you can't see all of it, and you're seeing a lot of this. Those are the atria. They're collecting, these atria, either collecting blood from your body or they're collecting blood from your lungs. Atria are all about collecting. Okay? Ventricles, the bottom two chambers, are all about pumping. When you go back here on the outside, you can see the structure looks different. This looks more like a bag up here, the two atria, and the bottom part of the heart looks very strong and muscular. Okay, those are the ventricles. They're about pumping. So we need to add to our song. So do the first part of the song with me. Arteries go away from the heart, veins go towards. Arteries, arterioles, capillaries in the middle, venules, veins. Now go here. Heart, body, heart, lungs. Okay, repeat that again. Heart, body, heart, lungs. Heart, body, heart, lungs. Now, the next part is I want you to know what you call those circuits. It goes heart, systemic, heart. What's the name for lungs? Pulmonary. Okay, go again. Heart, systemic, heart, pulmonary. Heart, systemic, heart, pulmonary. Atria, collect, ventricles, pump. Do it again. Atria, collect, ventricles, pump. From the top, you do each of those twice. Here we go. Arteries go away from the heart, veins go. Do it with me. Here we go again. Arteries go away from the heart, veins go towards. Arteries, arterioles, capillaries in the middle, venules, veins. Heart, body, heart, lungs. Heart, body, heart, lungs. Heart, systemic, heart, pulmonary. Heart, systemic, heart, pulmonary. Atria collects, ventricles pump. Atria collects, ventricles pump. Yay. Okay, now.
Yay.
If I took this heart, okay, and I'm looking now at the inside, the collectors are here and here. What are those called? Atria. Okay, these are the ventricles. What's their job? Pump. They're either pumping blood to the what circuit? Systemic or the pulmonary. Perfect. Okay, now I'm going to simplify our heart, okay, into these 4 boxes. Okay, so now let's apply what we know so far. Okay, blood that is coming here, coming from the body. Remember, blood is not red and blue. I'm just doing it for simplicity, okay? So blood coming into this chamber, it's on this side over here. So this would be my right. It is a collector, so it would be a atrium. Good. The blood's going to go down here into this chamber. This is still on my
Right.
and it's a pumper, so it's a
Ventricle.
right ventricle. The blood is going to go up and out. It's going to get some oxygen at the lungs, pulmonary circuit. It's going to come back into this chamber. This is now on the left side. It is a collector now from the lungs. It is my left atria. It's going to come down into this left ventricle, who's going to pump it out to the body. And that's going to be part of my what circuit? Systemic. Do you see the flow? Okay. Now, when it goes to the, we're leaving the right ventricle here. Is it oxygenated or deoxygenated? Okay. So it's going to need to go out, and you have 2 lungs, which are not empty sacs. They're containing millions of little air sacs called alveoli. Say that word. Alveoli. Good. When they head out, okay, you're going to each lung. This one over here, what side is this? Left. And I'm going to the lungs. So what word am I going to use? Pulmonary. Yes. You're already there. Okay, I'm going away from the heart, so it has to be a artery. This is an artery that is carrying what kind of blood? Oxy or deoxy?
Deoxy.
Okay. This one over here would be my,
Pulmonary.
give me the first word. Right. Pulmonary. No. I'm going away. Right. Pulmonary artery. I'm going away from the heart. Away from the heart. So this would be my, oh, okay. Okay, this one over here would be my right pulmonary artery. When I come back from the lungs, am I oxy or deoxy?
Oxy.
I am oxy. When I come back and come into here, let's think about the name of that vessel. Don't tell it to me out loud. Whisper it to your bio buddy. What would be the vessel coming to the heart here? Go. Talk about it with your bio buddy. Okay, got guesses? I'm on this side, so it would be my left. Where did I just come from?
Pulmonary.
Pulmonary?
Vein.
Vein. This one over here, coming in from this lobe of my lung over here, is going to be my right
Pulmonary vein.
We good?
Yeah.
Coming in, left atrium, left ventricle. I'm going up and out to my body. Largest artery of my body. Aorta. Okay, got it? Nothing. So it's not memory. If you logic it out and you just remember the three things, arteries go away, veins go towards. I need to know my lefts and my rights, and then I need to remember anything to do with lungs is pulmonary. Perfect. Okay, there are some valves here. The first set of valves I'm going to point out here are called AV valves. AV valves, right? Atrioventricular, AV valves. The one on this side is called a specific name is tricuspid. This one is mitral or bicuspid, and you can see rat.
Lab.
Yep.
Okay, thank you.
See rat lab?
That's creepy.
Lab rat. You can look at it.
Rat lab.
Do you see it? Help your bio buddy so that they can see it.
I see it. It makes me so happy.
I'm glad we took the time to think
I'm
about
glad we took the time to think.
Yeah. Do you know what it's about?
It's just for yearbooks.
Oh, okay.
I'm so happy.
Okay, you got that part? Now, I have one other thing to show you. The only thing we haven't named are the vessels that are coming in here, okay, to the right atrium. Now, one comes here from the top, so they'll sometimes call it superior, or it's in the front of the heart, so another name is anterior. So it's superior, above, anterior in the front. Use either name. And it's called vena cava. Okay, what do you hear in vena cava? Veins. Okay, then there's one that comes from down here, back behind the heart, and comes in. So it's not really coming from the side over here, it's coming up and in here. So if this would be superior, this would be inferior. Okay, and this one's in the front, this one's in the back. So instead of anterior, it would be posterior. Posterior vena cava. Okay, got it?
Yes.
Let's look at this and see if we can name some structures.
Let's do it.
Are we ready?
Yeah.
Yes.
Okay, so tell me, let's start naming. What is this? What is it?
Right atrium.
Good. Now, there's something bringing blood in. What would this one be right here that's bringing blood in?
Superior vena cava.
Okay, and this one down here?
Inferior.
Good. So this blood comes in through here. What's this valve right here? We'll
Tricuspid.
never forget that. Then down here we are at the
Right ventricle.
Okay. Up and out. Got another thing I need to teach you still. And out. This one over here is going to be
That's pulmonary artery.
Okay, this one over here is the
Right pulmonary artery.
Okay, touch base with your bio buddy right now and go, are you good on that? Do you get it? Does it make sense to you?
Yeah, I'm gonna use my J.
Okay, now, there is another valve There's another valve. It's this valve right here. Okay? Now, when the right ventricle contracts, there is a tremendous force on the blood. Same thing with the left ventricle, a tremendous force on that blood. And it'll want to send the blood right back from where it came from, but this valve, the tricuspid and the bicuspid, slam shut in order to prevent that. Okay? And when those heartstrings I showed you, they're holding them because they're slamming shut. And they're like, oh, oh, every time it contracts. When this right and left ventricle relax, it's like going, and it's sucking the blood back in. When it's relaxing, it's trying to send it away, but just the very nature of that contracting muscle, it's like, and it sucks it back. These valves right here slam shut. Now, when you listen to somebody's heartbeat, those are the valve doors slamming shut. Love dub, love dub, love dub, love dub, love dub. Those are the valve doors slamming, okay? And that's what you're listening to, and you can tell how fast the heart is beating. Now, if somebody's heart is going love dub, love dub, love dub, they have a heart murmur. And the valve is not shutting, so it's not a tight seal, so you could get a little bit of mixing of blood. Is that healthy? No. Sometimes heart murmurs are bad enough where they have to have surgery. Sometimes you have a heart murmur as a child and you grow out of it. So there can be variations on that. Okay, so this valve is important too. Now this valve and this one are called the semilunar valves. Now, I want you to look at a different picture of the heart. Take a look at this picture of the heart. What number do you think are the semilunar valves in this picture?
6.
I agree, 6. They're right here. So the blood's coming down, out. These are the semilunar valves. When you hear the word lunar, what do you think?
Moon.
When someone moons you, what do they show you? See them?
Ah.
Oh, thank you.
Semilunar. Just a little bit of butt. Okay? So come back here. Where are we? Okay? So these valves right here, that valve is the semilunar valve. Okay? Now, when the blood goes out, it's going to come back oxygenated. It's going to come back both of these. Okay? What are these two vessels called? Left pulmonary vein. Okay? And then coming back here behind the heart, these are going to be your
Right pulmonary vein.
Perfect. What's this right here?
Great atrium.
Left atrium.
Left atrium. Good. Valve.
Left.
Valve.
Bicuspid.
Good. Okay. Chamber.
Left ventricle.
And this is the largest part of your heart. Okay. Why? Because it has to pump blood to your what circuit? Systemic circuit. Okay? And what valve are we going through right here? Semilunar. This would be the aortic semilunar valve. Why? Because where is it going next? Aorta, which is right here. Now, your aorta, it has branches here, and then it turns around and comes down right here. That's still the aorta as well, taking blood to the rest of your body. Okay, now there's another thing we need to label, and that's right here. This dividing area between the left and right ventricles. This dividing of two chambers, it's the same name that divides these two chambers here. What's this thing? Sometimes people have a deviated one of them. Septum. This is a septum.
Exactly.
That divides those two chambers. Okay, got the logic? If you want to snap a picture of that, you can. But you could also, right, flip a pic. You could be finding a labeled picture of the heart, no problem, and tossing it into your notes on Google, right? You can search unlabeled, you can search labeled, and throw those in there. All right, get it? Get it? Now, I'm going to give you this part of the heart. Slate, you're doing all the odds. Blue, you're doing all the evens. Start at 1, ping pong back and forth. Go.
Number 1 is aorta.
Name full names.
Are they
Girls, maybe you can trifecta.
the left where is the attached to?
That's the left pulmonary vein.
What is the attached to?
9 is the left pulmonary vein. Number 5 that's the right cuspid.
Number 6.
11 is
Semi-lunar.
13 is left ventricle.
8 is septic.
9 right ventricle.
10. Systemic or the, oh, it's the vena thingy.
You have to remember it's superior.
It has like the vena, the one that sounds like Spanish.
Vena cava.
Yeah, the vena cava. Okay.
That's the vena cava.
That's the inferior vena cava.
Okay, vena cava.
Yeah, fine.
How did you do?
Number 11, tricuspid.
Any of them you need me to check with you? Yes. Let's look. What is 8? Guys, what is 8? Septum. Good. Anything else you need to go over? Yes.
For 10 and 15, one's superior, 15 superior, and 10 is inferior. But what is the after superior?
Oh, so what's another name for superior in this case? Anterior. Because it's more towards the front of the heart, whereas this one kind of comes in the back side of the heart. So you could have superior and inferior, or anterior and posterior.
And then what's after?
What comes in here? Here?
Vena cava. Okay.
Vena. Oh, I'm so sorry. The next vena cava. Sorry, I'm so sorry. I'm like after the right atrium. Okay, did you throw a labeled picture of the heart in your notes? Yes? She said, flip a pic, do your job. All right, next. Take a look at this, and we're just going to number, and you're going to not shout ahead of me, but you're going to tell me what things are, okay? And I'm going to show you the flow numerically. That was everything labeled. Now I'm going to show you pathway. So this just kind of keeps that straight. So I'm going to label both of these 1. What could you collectively call them?
Vena cava.
Vena cava, okay? And this would be?
Right atrium.
Okay, and give everybody, I'm going to go, and this would be, and then let people say,
Okay.
okay, so this would be the right atrium, and this would be?
Tricuspid.
Tricuspid valve.
Valve.
Good. And this would be?
Right ventricle.
Good. And here?
Semi-lunar.
And I'm making these both 6s. They are what?
Pulmonary arteries.
Pulmonary arteries. Okay? Then those are going to go arteries, then what? Arteries, arterioles, capillaries in the middle. Now, they're going to be the capillaries at the, I heard it, lungs, right? So there's still other vessels in between there. So I'm just going to say 7 is this. Right? Okay. So now I'm coming back from the lungs in what? Venules, veins, and then number 8 would be what? Pulmonary veins. And this would be? And this would be?
Tricuspid valve.
What valve?
Tricuspid.
This is the left atrium. We got to spell what word? Lab. So it's got to be bicuspid. Okay. Now we're here. Left ventricle, and we're here, and we're here, and then we're here.
Why is it different?
Why did I? Yes. Why did I do that? To represent oxygenated and deoxygenated. Right?
I know.
Okay. Got it. Questions? Ask your bio buddy. How do you feel on a scale of 1 to 10?
Oxygen. And
Oh, I
then,
get it now.
okay, good.
It took me a little bit.
All right. I got some questions for you. Let's see how you do.
Yes.
Let's get some hundies.
Yeah, it turned on.
What could you do if it turned off?
Turn it back on.
Mine turned off.
2015. We're in 5, baby. I'm so happy.
I think it's because not everybody's plugged in. 2,000, 2000 number.
Yin Yang play. Fall Out Boy. NSYNC. I like all these things.
Mariah Carey.
Mariah Carey. What's the hardest part of the vegetable?
Hear me. When there are going to be some questions coming up about the heart. Best thing to do when you get a heart question, imagine the box. Okay? Then see that chamber in your mind. Imagine the box, see the chamber. What are the three things you're going to always have to keep in your head?
Left and right.
Arteries go away, veins go towards. So anytime it says something going towards the heart, it has to be a what? Vein. If it says it's leaving the heart, it has to be a artery. What else are you going to keep right? Left and right. Okay, and what's the third thing? Anything to do with lungs is?
Pulmonary.
Good. Are you going to get a hundy on this?
You better.
I hope so.
Yay!
So proud, Red Hot Chili Peppers. Tell your bio buddy good job. There's no shame, only gongs.
Thank you.
All right.
Let's go again.
Usher, all these people are.
Be a winner. Be a winner. Be a winner. Chicken dinner. I had chicken last night. Barbecue. Did you have like 10 grass fed? It was good. It was what? Grilled chicken.
I can't go
Did you have
for
a
burger.
salad? Oh.
Did you screw this up? Tell me you did not screw this up.
We have rice and a salad. But I put everything in my salad. It doesn't matter what we eat, it's all the rice. Rice goes in my salad. The chicken goes in my salad. I eat a bowl of the salad. All of it.
I also go to right.
Okay, are you imagining this box? Okay, tell me when to stop. Where's the right atrium?
There.
This one right here is the right atrium?
Yeah.
You're sure? 100% sure?
Yeah.
Okay. And it's entering the right atrium. Let's go, Psalm 41. Make a commitment. Okay. Please. Please. Is it going to be good?
No.
Oh.
Look at your Bio Buddies clicker right now. If they have a shame bell ringing, please guide them in their decision making right now. Have that decision. Okay? So, if it is entering the right atrium, okay, if it's entering the right atrium, it's got to be a what? Artery or vein? Vein. So, who can I cross out?
Aorta and pulmonary arteries.
And nobody picked A or C, right? So they got that part down. Where their struggle was is they couldn't remember which one it was. They had to choose between pulmonary and vena cavas. If it's entering the right atrium, has it been to the lungs yet?
No.
No. Is its next stop the lungs?
No.
No. Its next stop is the right ventricle. Okay? So that's how you want to think it in your head. Just be real logical. Okay, you have another opportunity. Here you go. Be a winner. Why would you not go in? So I'm going to have you go right at 10. Right at 10. Yes. Will it be a hundy?
Come on. Find that person.
Oh yeah, Usher.
Weezer.
Oh my gosh, Weezer, it took you 9 seconds to fail with your friend Panic at the Disco. Okay? Shame. Show your bio buddy the clicker right now. Are you shameful together? Is it help them, guide them? 9 seconds to fail. See, I appreciate it. You took more than 9. Thank you, Madonna. You took 10 seconds and got it right. Good job, Madonna. Good job, Green Day. Train. Even Mariah Carey. You might have forgot at first what you were supposed to say, but then you remembered later. How horrifying. That would have been horrifying.
Who screwed this up?
I actually.
There's too many songs.
So weird.
Beyonce.
Let's go, No Doubt. Put on your red lipstick. Can't wait any longer. Okay, hang on, I gotta go off it to force it to go. Hang on, that's not it, it's not it.
Oh, is that one person? Is that you? Okay.
Madonna skipped and Sum 41. Took you 14 seconds to fail. Be like No Doubt. No Doubt took 28 seconds. Show your bio buddy your clicker. Shame or praise? Chastise, guidance, what do they need? Let's help them by helping them walk through the logic of it all. Tell me where the right ventricle is. Here?
There it is.
There it is. Vessels leaving. Oh, yay. Late to class, but time to go to Starbucks, huh? Did you bring me one? No. Okay, fine. I see how it is. Okay. So, okay. I'll say exactly what I want. Okay, so vessels leaving the right ventricle. If you're leaving, you've got to be an artery. If you're going away, right? Okay, and so we're leaving the right ventricle, so where do we need to go? We're deoxygenated blood. We need to go to the lungs, so that's why we do pulmonary arteries. What did they say? What did they say? C. Aorta. No.
That's just
Last chance. I believe in you. I believe I can fly.
There we go.
If someone speeds us up, I can be really angry.
I like how they've all been the same answers.
What?
I like how they've all been the same answers.
Look at, he's doing it again.
He's always doing it.
Corey in the house is like,
You can see your eyebrows.
I'm not entirely sure what to make of that.
All of us.
Oh my.
How did this even
Red Hot Chili Peppers, 4 seconds to fail. Killers, 19 seconds to fail. There was only one left. I asked 4 questions about the heart. Okay, so left ventricle on this side, it's the biggest, strongest part of your heart. It's going out the aorta. Okay, let's go to our notes and fill those in. The human heart, the atria collect what? What do they collect? Blood. And depending on which atria it is, it's either collecting it from the body or the lungs. The ventricles what? Pumps blood to what? The body or the lungs.
It's a very important anime.
Heart valves direct the flow of blood. The atrioventricular valves are between the atria and ventricles. They are one-way valves. Semilunar valves between the ventricles and... Any guesses? Arteries. Oh, you do have that one?
Yeah.
Oh, yeah, that's not much of a guess then. Okay, aorta or pulmonary arteries. Good. Now look at the blood pathway through the heart. Okay, you have some blanks in there. Apply your learning, and as a team, fill in the blanks.
It's like
Use your large mammalian brain. Fill in the blanks.
I filled in those.
Yeah.
Yeah. Wisdom through that last week, so I had the 1 week test.
How did that go?
Good. They just looked there. You're fine.
Did you have no swelling?
I did, but it was.
I looked like a chipmunk when I got
Yeah, I was slightly too warm for this.
Oh, I was not slightly. I was like mortifyingly a chipmunk.
I have pictures.
Oh, I want to see those pictures.
Do they give
All right, let's check your, did you fill it all in? Who needs more time? What team needs more time? Go for it, team. Let's go. Delay of game, penalty 5 yards.
5 points in your next test.
That's right, 5 points on your next test. You're slowing us down. Be a winner. All right, what'd you put for 2? Right. Good. 5.
Right. Oh, wait.
5. Just tell me what 5 is. What'd you put for 6? 8. Good. 9.
alveoli?
Yes. Capillaries around the alveoli of the lungs. What'd you put for 12? Pulmonary veins. Good. Number 13. Left atrium. 17. 17. Aorta to the body. What did you put for 18? And 21. 22. Veins. Good. Give yourself a letter grade and tell it to your bio buddy. How well do you feel like you understand that?
A.
A for it.
What one did I skip over? 11 is veins. Sorry, I didn't highlight that on mine. I didn't know I made that go bye-bye. Yes. I can't hear.
Number 8.
What is 8? Arterial. Any other ones? Bueno? Okay. So now your heartbeat, some stats. Okay, 70 beats a minute. Some of you probably have a lower resting heart rate than 70 beats per minute. Best way to get your resting heart rate is if you wake up in the morning. I'll wake up in the morning. Okay, and all right, sorry. So you wake up not due to your alarm clock. If you wake up due to your alarm clock, what might you be doing? Exactly. So that's going to increase your heart rate, fight or flight, adrenaline. Okay, startle response. If you wake up naturally and you can see a clock somewhere and you can, time or whatever, that would be your resting heart rate. You can see what you are. Okay. Now, when your heart contracts, why this is next? Okay. When you look at your blood pressure and you use a sphygmomanometer in order to get your blood pressure, okay, and basically what it does is it compresses on your brachial artery, it compresses your whole arm, okay, but it compresses it and it shuts down your brachial artery, literally shuts it down. Then the cuff slowly releases the pressure on that brachial artery, and the blood is trying to get through that brachial artery, and then the cuff will then detect it. And I have digital blood pressure cuffs. You can measure all of that, okay, in your lab. And it goes through, and at the point where it will first be able to get through, you'll measure that, and that'll be your systolic pressure when it's under the highest pressure. And then the cuff will not be giving any resistance at all, and it goes through evenly. That won't be the systolic, that'll be the diastolic, okay? So a sphygmomanometer, one of these, okay, it measures the blood against the walls of the blood vessels, okay? And it can vary due to all of these things. Could Slate explain why do you think it'll vary due to these things? Go ahead, Slate.
Well, like your heart size, like weird if you're running or like exercising or whatever, the elasticity of the arterial wall for the time how like if you've been eating well or whatever. If you have if you just do another thing, the volume and viscosity of the blood, that I guess comes with
All right,
different.
Let's create a trifecta. Okay, we have a 55-year-old overweight man. Okay, are you envisioning your 55-year-old overweight man?
Thank you.
Okay, it's a good picture.
Thank you.
Pants are low below the gut, maybe a little too much beer. Okay, getting that belly here, that belly fat. Okay, now it's possible that this overweight 55-year-old man, his arteries are what? Clogged. Now, this is what's going to happen. When your arteries are open, it's kind of like those party balloons that you use to blow up with a little helium tank. You could blow those up so easy. It's like, they just blow up. Okay, now imagine those little tiny water balloons.
Oh.
You ever tried to blow those up and you know, you can feel it, the pressure back here, it's hard, okay? Same thing for their walls, okay? If they get clogged, if you have some atherosclerosis and you got some, you know, buildup, some plaque in there, the vessel that should be open, a larger lumen, now has a smaller lumen. Is it gonna be harder or easier to get blood through that lumen? Harder. The heart will then have to pump harder to get it through that small little space. Okay? So is the blood pressure going to go up or down? Up. Now, let's say they're eating a bunch of salty food. Okay? A bunch of salty food. And now they have a lot of salt due to digestion and absorption, a bunch of salt in their blood. Is it going to make their blood hypertonic or hypotonic?
Hyper.
What's going to flow in? Water must flow from the hypo, and it's going to flow into the hypertonic. Water will flow into your blood. You'll maintain more of it. Now you have more blood. Do you think it's going to be harder or easier to pump around more blood? Harder. Blood pressure now is up. Now they are sitting up, eating chips, okay, and maybe drinking a beer at late at night, waiting for their daughter to come home on her date. It's now 1 in the morning, and she has passed her curfew. And they are getting upset about it. So now they have the complications of some hormonal things going on, anger, and the daughter comes in late and says, "What?" Okay? Now what can happen? Right.
He's gonna get slapped.
Hopefully not. Okay, but then what's going to happen is this could set you up to have a what? Heart attack. Okay? So things like complication of diet, lack of exercise, poor choices, stress management, those kind of things can lead to overall blood pressure that's high, and it makes you more likely to have one of those types of cardiac events. Yes?
So I've noticed when I have like sushi and like soy sauce.
Yes,
salty,
totally.
Or any other salty food, like my fingers get like puffier the next day. Is that
Yes.
part
Does
of
that
it?
make sense to you? Why would your fingers get puffy? Because of the high salt. If you weigh yourself, you will notice the next day after a high salt diet, you will weigh more than you normally weigh. I remember March, St. Patrick's Day, corned beef and cabbage. At a very good cook, I remember we were eating corned beef, tasted delicious. It didn't taste overly salty, but I guess it's a cured meat with a lot of salt. I can remember going home and watching TV, and I can feel my heart. I thought it was going to come out of my chest. I was just like, ugh, my heart is beating too hard. And it kind of stressed me out because I could feel it. And I wasn't exercising. I was sitting on the couch watching TV. So you have to be careful of those, especially people with high blood pressure. You have to watch out for salt in their diet because if you already have other problems, it can complicate it. Okay? So who explained this right here? Slate did, yeah?
Yeah.
Okay, Blue, this is your picture. I'm going to give you before and after on this picture. So start with the before and then I'll give you an after. Go ahead. Explain to me.
So the cardiac segment, at 150 seconds, systole, the atria, and then the ventricle, diaphragm, and then at 0.3 seconds, it's
So I'm going to jump in there. Systolic is when you have the greatest force on the blood due to the heart. Diastolic is when the ventricle is relaxing and there's less force. So the way I remember it is that if the ventricles relax permanently, then you will diastolic. Okay? So relaxing under diastolic. So when you look here, when your ventricles are contracting, that's systole. When they're relaxing, that's diastole. But your blood pressure measures just this part. The left ventricle is what it's measuring, right? Because when you take your blood pressure out on your arm or at your wrist, when you're taking, that's part of your systemic circuit. And who pumps blood into your systemic circuit? The left side. Okay. So on your notes, go to systole. is when the heart chambers, the ventricles are what? Contracting. Good. And diastole is when those heart chambers are relaxing. And then the heart sounds, already talked about that, lub-dub. The AV valves, then the semilunar valves slamming shut. The AV valves, then the semilunar valves slamming shut. Okay, your pulse is the expansion of arterial walls due to the heart contracting and forcing blood through the vessels.
You feel it?
All right. What?
What kind of valves?
What are you on?
3.
3. Heart contracting and forcing blood through vessels. Okay. The cardiac conduction system. Or did I get you? You all right? Okay. Hope I put the right notes in there. Cardiac conduction system. Now, if you took heart cells and you dissected some heart cells out and put them in, from a living heart, okay, immediately, like you just took some off. Obviously, maybe life's not going to happen after that, okay? Some mammal, okay? And then you put it in a dish, maybe even a frog. Put it in a dish in an isotonic solution with glucose. It'll sit there in the dish and beat that single cell,
That is
okay,
so
of the
cool.
heart. And then you could put another one in there and it would sit there and beat as long as an isotonic solution with some sugar, okay? And then if you push them together, they would start to beat together, okay?
That's so cool.
Your heart tissue is amazing. And it's a mix in certain areas between nervous tissue and, girls, yeah. Nervous tissue and your cardiac muscle. And this node right here, okay, this node is called your SA node, sinoatrial node, SA. Okay, SA comes first, okay? And it sends a wave of depolarization across your atria, and then your atria will contract. And when that wave of depolarization hits what's right here, this is called the AV node. What do you think AV stands for? Atrioventricular node. Good. Then it sends a wave down here. This is the bundle of his, and then the Purkinje fibers, and then the ventricles contract. So it goes like this. Atria, ventricles relax. Atria, ventricles relax. Atria, ventricles relax. And you want them to contract the 2 atria at the same time and the 2 ventricles at the same time. If they start going like this, okay, that's when you need a clear, okay? You need a defibrillator to reboot your heart. Think about it like your computer when you have too many apps open and then it won't do anything, or it just spinning wheel of death's going.
Oh my gosh.
What do you ultimately have to do?
I just shut
Turn
it
it off.
off.
So what you're trying to do when you use your defibrillator is put enough electricity, because this is electricity that's moving across the heart, that the heart goes, seizes, kind of seizes and then relax, and then hopefully reboots it. Now what tells your heart to beat? Who talks to the SA node? The SA node is called the pacemaker because it's triggering the heartbeat and the pace of it, but really it's not setting the pace. What's setting the pace is our nerves from your medulla oblongata that go to the SA node and trigger that heart to beat. And normally you see things like this that's measuring the electrical stimulus across the heart. D, D, right? D. Now, when you see something that looks like this, that's not good, okay? Because you're not getting that clear rhythm of the heart, and the blood can move in different directions. And that's when you have to use a defibrillator. Okay, so on your notes, go to cardiac conduction system. The heart beats on its own. The heart beats on its own, but the rate is determined by the nervous system. And that's the medulla oblongata. The sinoatrial node is called the cardiac pacemaker, the SA node. And if you need a pacemaker, if that one's broken, they don't put it all the way into your heart. They just slip a little battery-operated disc right underneath your ribs to send that stimulus, in. Okay, so sinoatrial node is the cardiac pacemaker that initiates the heartbeat, causing atria to contract. Atria to contract. The AV node, when stimulated by the SA impulses, sends impulses through the septum to cause the ventricles to contract. To cause the ventricles to contract. Okay, and then this is a measure of the depolarization and repolarization on your heart. So this is called an electrocardiogram, recording the electrical changes that occur during the contraction of the heart. That occur during the contraction of the heart. And if you ever go to the hospital, how many of you have been to the hospital where somebody is hooked up to one of these? You seen this? Okay. So this first wave is smaller right here, and the P wave is measuring when the atria contract. Both atria are contracting. This QRS, what do you think's contracting then? Ventricles. Why would it be so much bigger?
It's more pressure.
Yeah, it's stronger. It's a bigger heart. The atria just have to contract enough to squirt the blood down into the ventricles. The ventricles have to contract enough to send the blood all the way to your lungs, or more all the way to your body and your systemic circuit. The T wave is when the ventricles, when the ventricles are relaxing. So what are we missing? We have atria contract, then we have ventricles contract, and then ventricles relax. What are we missing?
Atria.
Yeah, and it happens at the same time when the ventricles are contracting, the atria are relaxing, because otherwise they would send blood both ways, right? Okay, so the atria have to relax when the ventricles are contracting.
Wait, I have a question.
Yes.
So are the ventricles relaxing while the atria is contracting?
Yes. Now, you don't see this here because it goes like this. Atria, okay, that's your P, right? Then these are going to relax. Ventricles, rest. That's why you don't see the overlapping. It's not like this. It's atria, ventricles, rest. Atria, ventricles, rest. Okay, and we see that too in this diagram right here. Okay, so when the atria are in systole, the ventricles are in diastole. And that's very short, right? 0.15 seconds. Then now the atria are in diastole, they're relaxing, and the ventricles are in systole. That's twice as long because it's pretty big. Then both of them are relaxing. So this would be the P, this would be the QRS, and this would be the what? T. Does that make sense? Okay.
I see.
I see. Now here, a defibrillator. Has anybody ever been trained in a defibrillator?
No.
Okay. If somebody is having a heart attack and they are in fact looking like they might die, don't say, I don't know how to use a defibrillator. Okay. The defibrillator talks to you the whole time. Okay, literally. Okay, and a long time ago I got trained in it. I haven't been trained since. Maybe, I would screw up under those conditions. Hopefully not. Okay, but when you hook it up, okay, it will ask you, look, listen, and feel. Remember all the things you learned in health to even check their pulse, see if you can see the chest moving. It'll tell you to do all those things. When you apply these pads, it shows you exactly, put the yellow one here, put the red one here. And you see how it goes across, just like your SA node, AV node, it goes across, it comes with a razor. So in case they're a hairy beast, you can and shave them real quick. Don't worry about razor burn. Slap those on there so they have good contact so the electrical stimulus can go across it. And it'll tell you when to clear and do everything. It tells you, it walks you right through it. Okay? So don't be afraid of that if it happens. Okay? And you did a good job, and we will pick up here next time. and you're super smart, and have a piece of toast.